All right, let's get started with Chapter 4. Looking at Section 4.1, we're going to put a little focus on absolute value functions because they're solved a little differently than other types of functions. So we're going to look at this graphically, a definition for the absolute value function, because we have some strange things happening here. Because when we want to graph this, let's say we know it's a V shape from Section 3.4, so we need to create the V. So if we tested some points, like let's let x be 0, so the absolute value of 0 is 0, so y is 0. I test the 1, absolute value of 1 is 1. Test the 2, absolute value of 2 is 2. Test the 3, absolute value of 3 is 3. And there's the right side of my V shape. Now if we test the left side, absolute value of -1 is a positive 1. So we'll have a point here. Absolute value of -2 is 2. Absolute value of -3 is 3. And there's the left side. So this graph has what we call a sharp corner. And my absolute value function can be redefined because technically I have two linear functions here. All right, when I did the right side, notice that the slope is going up 1, right 1, up 1, right 1. So this is the equation 1x plus 0 because I'm going through the origin. And my second line over here in red, this has a negative slope, down 1, right 1, down 1, right 1, down 1, right 1. But we can't have it a function where x would have two different values here. So we'll let the 0 be part of the positive line, and we'll think of our red line having an open circle here. We won't touch it. So this, like I said, broken into two different individual functions. And when that happens, we call this a piecewise function. So in red, the function is y equals -x. Except that's for all x's less than 0, which are negative x's. So when you put a negative x in, say -4 into -x, you get a negative times a negative. That creates the positive 4. So it keeps everything still positive. And for the positive x coordinates and 0, we have 1x. And that's for all the positive x's. So this function can be broken into a piecewise function made up of two linear functions, one with a negative slope, one with a positive slope. So we know for a fact that the absolute value of -4 is 4 and the absolute value of +4 is 4. And if we opted to put x's in place of the -4 and 4 and rewrite it as the absolute value of x equals 4, okay, well, the 4 on the outside didn't change, so my answers here have to be -4 and +4. So what I need to do to solve absolute value equations is I have to realize that I have to have two answers, one positive, one negative. So if your absolute value is equal to a positive number, that's going to be a true statement. And so what we're going to do is we're going to take and make a positive case and a negative case. We'll make the 4 a negative, and we'll make the 4 a positive, and we drop the absolute value bars, and whatever we have in this absolute value bars for a variable expression, set it equal to these two numbers, and then solve for x. So you need a positive case and a negative case. And before you can make these cases, as I mentioned, you have to make sure these absolute value bars are isolated. No adding, subtracting, multiply, dividing to the outside of the absolute value bars. So we need to isolate them. All right, so if and when I isolate my absolute value bars and it's equal to a positive value, then we can do this positive and negative case. But if I isolate my absolute value bars and it's equal to a negative value, that's never true. When you take the absolute value of some number, you're supposed to get a positive value. If we set it equal to a negative value, there will be no solution possible. All right, let's look at some examples. Example 1. All right, absolute value bars here on the left. It's not isolated. I'm adding 11, so let's subtract it to the 38. 38 minus 11 is 27. It's positive, so we can continue. We'll make a positive case. 2x minus 5 equals a positive 27, which you really don't need to put the positive there. I'm just overemphasizing it's a positive case. This is the number that has the sign change. You never change the left side or what's in the absolute value bars. Well, maybe we will. Negative case, 2x minus 5, the inside of the absolute value bars, now set equal to a negative 27, and now we solve this. All right, so what we're looking for is what x gives us a positive 27 to do in the absolute value bars. So add over the 5, 32 divided by 2, x equals 16. What do we have to have for an x to give us a negative 27 in the absolute value bars, which again will produce a positive 27? Well, add over the 5, same thing as I did over there, then divide by 2, negative 11. So you can do these each separately, or because you will be doing the exact same work to get x by itself, you could say, well, I'm going to add 5 twice. Add the 5 over, add the 5 over. Get both of these. Then divide by 2, divide by 2. It's going to be the same steps. All right, number 2. Whoa, 2 absolute value bars. But wait a minute, the one on the right is a number. We can simplify that. The absolute value of negative 18 is technically a positive 18. Oops, I forgot typing in our answer into my math lab, 16 comma negative 11. Again, watch in my math lab if they want this to be a numerical order, make sure there's no commas, that kind of thing. Well, I'm good. Absolute value bars are isolated. I simplified this to a positive 18. We want this to be positive to continue, so positive case, 3x equals positive 18. Negative case, 3x equals negative 18. Divide by 3, divide by 3. Answers, x equals 6, comma, negative 6. There they are. Number 3, all right, isolate the absolute value bars. We have a positive 7 minus the absolute value bars. So if I subtract the 7 over, that makes this a negative 4. Now, because it's negative, I don't need to stop and say no solution because I still haven't gotten rid of this negative yet. So again, think of this as negative 1 being multiplied to my absolute value bars. So I divide the negative over to the negative 4 and make it a positive 4. Good, I can keep working. Make a positive case, x minus 1 equals a positive 4. Make a negative case, x minus 1 equals negative 4. All right, add 1, 5, negative 3. There's my 2 answers. Number 4, we have the fraction 7/3 being multiplied to my absolute value bars. Get rid of that multiplication. You can either divide by 7/3 or it's faster. Since we don't divide by fractions, we multiply by the reciprocal to both sides. So everything cancels here. 7 goes into 14 twice. And 2 times 3 is 6. So now the absolute value bars of 3x equals 6. We're just like above here. Make a positive case, 3x equals positive 6. Make a negative case, 3x equals negative 6. Divide by 3, divide by 3. X equals 2, x equals negative 2. There's my 2 answers. Okay, example number 5. Now we have our absolute value bars of x minus 9 is equal to, wait a minute, 0. 0 is neither positive or negative. All right, well, it's not negative, so we can solve this, but because it's 0, you won't need a positive case and a negative case. So just drop the absolute value bars and set it equal to 0. Only one equation to solve for. Add over the 9, take the square root, plus or minus 3. There's my 2 answers for x. Both 3 and negative 3 will cause a 0 inside here, and the absolute value of 0 is 0. Number 6, another x squared minus 3x in the absolute value bars. It is isolated. It's equal to 10, so we'll make a positive case. X squared minus 3x equals positive 10, and we'll make a negative case. X squared minus 3x equals negative 10. All right, let's solve the positive case. Subtract the 10 overs. set it equal to 0 because it's quadratic. And let's see if we can factor this. So look at the constant. What two numbers multiply to be 10 and subtract to be 3? Or if you want to say negative 3, that's fine. I would have to subtract a 5 and a 2. So 5 minus 2 is 3. So since 5 is the biggest factor, it's going to get the minus sign in the binomial, and 2 will get the plus sign. So there we are all factored out. Solve for x, add over the 5, subtract over the 2 to the zeros when you write these out individually. X equals 5 and negative 2. For my negative case, I guess I had one of my clicks out of order. Add over the 10. Again, it's quadratic, set it equal to 0. Let's see if this factor is what two numbers multiply to be 10 and add up to be negative 3. Well, if we're going to add up to be a negative 3, both numbers have to be negative, and they have to be smaller than negative 3. So my only option here is negative 1 and negative 2, which will add up to be negative 3. However, negative 1 and negative 2 don't multiply to be 10. So this is unfactorable. So if something doesn't factor, remember back in the day, you go to the quadratic formula. When you want to solve for x using the quadratic formula, the first thing you evaluate is the inside of the square root. Because if this is negative, you can't take the square root of a negative, there will be no real solution. So always evaluate this first. So b squared minus 4ac. B is negative 3, but again, because I'm squaring it, I'm not going to put the negative on it. Minus the 4, a is the 1 in front of the x squared, c is the constant 10. I'm going to get 9. 4 times 1 times 10 is 40. 9 minus 40 is a negative 31. All right, I can't solve this. There's going to be no real solutions here. So this is my only answer. 7. Okay, let's isolate the 5x plus 8 in the absolute value bar. Subtract over the 13. We get, whoops, 4 minus 13 is negative 9. Remember we said if my variable expression inside my absolute value bars is isolated and it's equal to a negative value, we're done. It's no solution. No reason to go any further. All right, number 8. Ooh, another quadratic. Getting a heavy dose of those. It's equal to 4, so everything's good. So make a positive case. X squared minus 2x minus 4 is equal to positive 4. Make your negative case. Make the 4 negative. It's quadratic, set it equal to 0. Subtract over the 4 makes us minus 8. All right, let's see if we can factor this. Two numbers that multiply to be 8 and subtract to be 2. 4 and 2. And since our 2 here is negative in the middle, the 4 gets the minus sign, the 2 gets the positive. Because when you have a negative constant, your binomials will always have opposite signs. There was the minus 10, opposite signs. The sign of the middle term always goes with the bigger factor. Solving for x, x minus 4 equals 0 means x is a positive 4. X plus 2 equals 0. Subtract over the 2, x equals negative 2. There's my two answers. To the negative case, again, add over the 4, so it's set equal to, whoops, if I add the 4 over, I'm going to cancel this 4 out. So it's now x squared minus 2x equals 0. This will factor because there's an x in each term, so I'll take out the GCF of x. Leaves me x minus 2, so x is equal to 0. X minus 2 equals 0, which means x is equal to a positive 2. So here, all 4 of these will work. I have 4 answers that will work. All right, example number 9. Boom. Our absolute value of negative 7x plus 2 is equal to a binomial. That's okay. We'll treat this like one number. And we're going to assume it's positive. So here's something we're going to want to check this to make sure our answers work. Okay, so positive case, boom. Positive that binomial. Now, do I really need again to put the positive in front of the binomial? No, that's okay. I don't have to. All right. Negative case, Put the negative in front of the binomial. Yes, now I need the parentheses because I will have to distribute that. All right, so let's test it. Negative 7x plus 2 equals x plus 18. All right, let's add, oops, not add over the x, subtract the x over to the left. That's going to make it negative 8x. We'll subtract the 2 over to the right to the 18. That will make it 16. And we'll divide over the negative 8. Makes x equals negative 2. All right, so if I test this, negative 7 times negative 2 is 14, plus 2 is 16. The absolute value of 16 is 16. Negative 2, put in for this x, negative 2 plus 18 is 16. All right, that answer works. Negative case. All right, here we go. Make the negative, distribute it in there. Both signs change. Okay, add over an x. So this negative x will add it over, make this negative 6x. Subtract the 2 to the minus 18. That's going to make it negative 20. We'll divide by negative 6. And reduce and simplify. This gives me 10/3. All right, so now I want to check to make sure this one works. So I would probably go to my calculator. One, because it's a fraction. You know me, I hate working with fractions. All right, so let's test it. Take alpha y equals fraction 10/3. Store it for x. And what we're going to do is we're going to type in the left side, and we'll type in the right side. And if both sides are the same, then they're equal to each other. It works. So math, go to NUM. That's your absolute value function right there. There's my absolute value bars with the text box. So negative 7x plus the 2. Enter it. 64 over 3. Then type in x plus 18. Enter. 64 over 3. So both of them worked. All right, number 10. Oh, wait a minute. We have a variable expression instead of each set of absolute value bars. So here's what you want to do. Pick one where you're going to drop the bars and make one positive and one negative like I did on the top. So I traditionally always leave the left side alone. So I'm going to leave this alone, but I'm going to make a positive case for positive 6x minus 5. And then I'm going to make a negative case. 2 minus x equals a negative times the binomial in parentheses 6x minus 5. It doesn't matter which one you do, just stay consistent. If I took this and put the plus and minus sign in front of this binomial and kept this the same, you will still generate the same answers. So 2 minus x equals 6x minus 5. All right. In this case, I'm going to add this x over so I can keep my x term positive. So this will be 7x. And I'll add the 5 from the right, the minus 5. I'll add that 5 over to the left. So we get 7 equals 7x. Divided by 7x equals 1. Distribute this negative, so that's going to be minus 6x plus 5. Again, I'm going to keep my x term positive, so I'm going to add 6x to the negative x, makes it 5x. And then I'm going to subtract the 2 from the left over to the right, so that's 5 minus 2 is 3. Divide by 5, I get 3/5. Again, if you want, check it. 2 minus 1, 1. 6 times 1 is 6, minus 5, 1. Absolute value of 1, absolute value of 1 works in both cases. You want to do the 3/5. Okay, let's see if I can do this between my ears. 10 would be 10/5, minus 3/5 would be 7/5. Okay, over here. All right, 6 times 3/5, that's 18/5, minus 25/5. So 18 minus 25 is going to be negative 7/5. But again, when I take the absolute value of it, it's going to make it positive in both sides, so it's going to work. All right, so that's how we solve our absolute value equations.